The James Webb Space Telescope has zoomed into the heart of a galaxy and released pictures of extreme starburst area. This galaxy is relatively compact in size but hosts a frenzy of star formation activity. This is the universe factory, and we will talk about how and what Webb telescope has observed with its infrared capabilities. Before we jump in, I'd like you to subscribe to the Universe Factory and press the bell notification next to it if you haven't already. This way you won't miss out with the latest update and happenings in the world of astronomy. Find us on social media platforms as well, links to which have been mentioned in the description down below. Be sure to check out. Now let's dive deep into this video. It's going to be super interesting. Let's begin. The James Webb Space Telescope has zoomed into the heart of the Cigar Galaxy, or M82, a region of space that is ablaze with an explosive bout of starbirth. For comparison, M82 is sprouting new stars 10 times faster than the Milky Way galaxy. The team of astronomers has used NASA's Space Observatory to survey this starburst galaxy. Located 12 million light-years away in the constellation Ursa Major, this galaxy is relatively compact in size but hosts a frenzy of star formation activity. The team directed Webb's NIRCam, or Near-Infrared Camera instrument, toward the starburst galaxy's center, attaining a closer look at the physical conditions that foster the formation of new stars. So what exactly are we looking here in these pictures released by the Webb telescope? M82, or Cigar Galaxy, has always been the subject of various observations, being considered as a prototypical example of starburst galaxy. But what do you mean by a starburst galaxy exactly? A starburst galaxy is one undergoing an exceptionally high rate of the star formation as compared to the average rate observed in most other galaxies. For example, the star formation rate of the Milky Way galaxy is approximately 3 solar masses per year, while starburst galaxies can experience star formation rates of 100 solar masses per year or more. Star formation is common across the cosmos, but has been able to maintain an air of mystery because gas and dust that forms the raw material necessary for the star formation also effectively shrouds the process. Fortunately, Webb's ability to peer into the infrared as an asset in navigating these murky conditions. Additionally, these NIRCam images of the very center of the starburst were obtained using an instrument mode that prevented the very bright source from overwhelming the detector. The JWST M82 shortwave infrared light image shows dark, reddish-brown tendrils of dust weaving their way through the white cigar smoke glowing core of M82. The small green specks in the image represent regions of iron that remain from the supernova explosions of now dead massive stars. The red-looking patches show areas where the molecular hydrogen is being heated by radiation from young stars. This image really shows the power of the JWST. Every single white dot we see in this image is either a star or a star cluster. We can start to distinguish all of these tiny point sources, which enables us to acquire an accurate count of all the star clusters in this galaxy. This galactic wind is powered by the star formation and supernova deaths of older stars. Like the lifeblood pumped through the blood vessels in the human body, the galactic wind moves elements around that allow galactic growth through further star formation. This is also helpful to gain insight on how hot and cold components interact within the wind. Webb's NIRCam instrument was well suited to trace the structure of the galactic wind via emission from sooty chemical molecules known as polycyclic aromatic hydrocarbons, or PAHs. The PAH can be considered as very small dust grains that survive in cooler temperatures but are destroyed in hot conditions. Much to the team's surprise, Webb's view of the PAH emission highlights the galactic wind's fine structure, an aspect previously unknown. Depicted as red filaments, the emission extends away from the central region where the heart of the formation is located. The team hopes that the further JWST observations of M82 and other starburst galaxies could help answer some nagging questions about the star birth. The researchers will also combine these new images with complementary large-scale images of the Cigar Galaxy and its galactic rings. Light spectra from this galaxy should help astronomers determine the accurate ages of the star clusters in M82. This could in turn reveal how long each phase of star formation lasts in starburst galactic environments. Webb's observation of M82, a target closer to us, is a reminder that the telescope excels at studying galaxies at all distances. In addition to looking at young, high redshift galaxies, we can look at targets closer to home to gather insight into the process that are happening there, events that also occurred in the early universe. Thank you for watching today's video, where we talked about the latest images of M82 or Cigar Galaxy taken by James Webb Space Telescope. Like and share this video with everyone around you if you got to learn something new today with this video. Subscribe to the Universe Factory and press the bell icon next to it. We constantly post latest happenings and news in the world of astronomy that you surely do not want to miss, just like these videos in the suggestions. We'll be back with yet another super interesting video for you soon. Till then, keep looking up.